Hi, and welcome to AR Maths Pro Learning Academy. In this video, I'm going to explain about relations and functions of Class 12, Chapter 1, Exercise 1.2, Introduction and Solutions, Part 1, from questions 1 to 4. Functions. What is a function? A function is a special type of a relation. That's it. In depth. Now, furthermore, if we talk about in depth, in a function, every element of first set belongs to domain, is related to exactly one element of the second set. That's it. Every element of the domain must be related with one element of codomain. That's all. This is the function. Let us have few examples. Is this a function? Check the first set. First set means set A. Okay. In set A, I have three elements: 1, 2, 3, and every element is related with one element of set B. See, like 1 has only related with B, 2 is related with C, 3 is related with A. No element has two relations. So the image of 1 is B. So this is a function. This is a function. Let us have one more example. Is this a function? No, it is not a function, because element 1 of set A has two images, A and B. That is why it is not a function. Another example. Is this a function? No. The answer is no. Why? Because this element 4 of set A has no image. This element has no image. That is why it is not a function. F is not a function since 4 has no image. Another example. Is this a function? Yes, it is a function, because every element has one image. Check. It has only one image. It has only one image. Yes, this has pre-images too. This is possible, but we need to check only set A. Every element of first set, which is domain, has a relation with set B. That's it. So this is also a function. Let us talk about types of functions. In our syllabus, there are only two types. The first type is 1-1 function, that is also called as injective. The second one is on-to function, which is also called as surjective. And both of them is called bijective. What is a 1-1 function? Injective function. Every element in domain means the first set, has a unique and distinct. This unique means only one, distinct means different, image in codomain, which means every element of set A has a unique and different images in codomain. Like, see an example. 1 has image B. The image of 2 is A. 3 is C. 4 is D. No one has two images, or two sets does not have one image. That is called 1-1 function. What is an on-to function? Surjective. An on-to function, you have to check in the codomain. Every element of codomain must have some pre-image. Some pre-image means it could be 1 or 2 in domain or more. Example, if you see this, for example, you have to check set B in on-to function. Okay, see the element A of set B has one pre-image, 2. The element of B has two images. No problem. It doesn't make any difference. At least it should be some image, one image, two images, or three images. And C has four. So every element of set B, every element of codomain must have a pre-image in domain. That is all about onto function. Let us have few examples based on this one. Now, at first, is this a function or not? Function says every element of set A must have an image. Yes, every element has image. Check. So it is a function. Is it a 1-1 function? Yes, every element has unique and different images. Check, unique and different images. So it is also a 1-1 function. Is it an onto function? Onto function means you have to check set B. Okay. Every element of set B must have a pre-image in set A. Yes, A, B, C, everyone has a pre-image. So it is also an onto function. Remember, if a function is 1-1 and onto, that is also called bijective, which means this function is on 1-1 and onto. Another example. Is this a function or not? Check. Set A domain has two images, so it is not a function. It is not a function. If it is not a function, which means I don't need to check 1-1 and onto. It is not a 1-1 function as well as onto. Another example. Is this a function first of all? Yes, it is a function because every element has an image, one image. Is this an 1-1 function? Yes. Is it a 1-1 function? No, because check, these two elements of set A domain has one image, which is B. So it is not a 1-1 function. This is not a 1-1 function. Is it an onto function? Every element of set B, every element of codomain must have a pre-image. So everyone has a pre-image. Check, this one has two pre-images. This one is, no, this one is not an onto function because C, element of B, element of set B is not having any pre-image. So it is not an onto function. Another example. Is this a function? Is this a function? No, it is not a function because element 4 of set A does not have any image in set B. So if it is not a function, which means it is not a 1-1 function as well as an onto function. 1-1 condition. For any A comma B belongs to set A is related with set B. If you see this function, it is many to one function because many elements is related with one element. That is why we say many to one function. We can prove that this many to one function is 1-1 function if A is equal B. Now if I equate them, if A is equal to B, if I say, that means only one relation. That means the given function is 1-1. So if f of A is equal to f of B, then we have to show that A is equal to B, then it is a 1-1 function. What is an onto function? The right onto function is pretty easy. Range is equal domain. What is domain? First of all, try to understand what is domain. Domain is nothing but set of all possible values comes out. All possible values. Whereas range, set of all values that actually comes out. We will give you example based on this one so that you can get idea. This is the one way to prove the given function is one onto or not. Another way, you have to check set B, which must have a pre-image in domain. You have to, every element of codomain must have some pre-image in domain. This is what we have to prove. If you draw the figure, you get better idea. like this one. Check, is this an onto function? Yes, every element of set B or codomain must have some pre-images in set A in domain. So it is a onto function. Note, keep remember these things. Okay, a function which is both 1 1 and onto is also called as bijective function. Another one, when a function is onto, then its codomain is also called as range. Range is nothing but a subset or equal to codomain. That's it. Come to exercise 1.2. Show that the function, this is domain r star to r star, defined by the function f of x is equal 1 over x, is 1 1 and onto, where r star is the set of all non-zero numbers. Is this the result true? If the domain r star is replaced by n is nothing but natural numbers, with codomain being same as r star. Now here r star is defined as set of all non-zero numbers, which means r is a real number except 0. R star is a real number which is a real number except 0. If I plug in all values, all real numbers, okay, in set A, and I'm plugging the values of x here, I'm getting some value, which means the result in set B, which is also a real number except 0. So check, every element has an image. Every element. I didn't draw it, but there must be some image here. There must be some image here. So if I draw the picture like this, a rough picture, then you get the idea whether it is a 1 1 and onto function. Now, if I see this one, it is, by drawing the figure, it is a 1 1 function, as well as an onto, but I will prove onto later. Now, let us prove 1 1 function first. Let x comma y belongs to r star, which means any real number, such that f of x is equal f of b. This is the condition of a 1 1 function. If f of x is equal f of y, now what is the definition? What is the definition says? F of x 1 over x, and f of y means 1 over y. Just cross multiply. If I cross multiply, I got x is equal y. I told you, if I prove x is equal y, then the given function is 1 1. This is the definition says, no? Since x belongs to domain, there must be an image in y belongs to codomain. So the given function is 1 1. Now I have to prove the given function is onto. Onto means for every codomain, every element of codomain, there must be a pre-image in domain. Then only I can say this is an onto function. Now try to understand, the given function is this one, right? The given function is, which is f of x is nothing but y is equal 1 over x. Y equal 1 over x. Now if I switch the values of x and y, if I cross multiply, okay, then x is equal 1 over y. This is y, okay. Take any values of y, any values, and plug in here. I will get some pre-image in x. Any value, you can plug in any value except 0, because the definition said r star. So I'm getting some image. That is what I said. For all x, y belongs to our codomain, there exists and x belongs to R, which is in codomain, under the function f of x is equal 1 over x. That means the given function is onto function. In the second part of the question, we have to replace the domain R star by a natural number, whereas codomain being same. In this part, we replace the domain as natural numbers, all natural numbers. Natural numbers means which starts from 1, 1, 2, 3, so on, positive. Mapping with R star, defined by the same function f of x is equal 1 over x, whereas R star is all real numbers except 0. Now draw the figure. Once you draw the figure, you get more idea. Now set of all numbers in set A, all natural numbers, which starts from 1, 2, 3, 4, so on, and set B, which is R star, all real numbers except 0. So minus 1, minus 2, minus 0.3, minus 0.7, minus 1.5, all negative, decimal, positive, all numbers are in set B. Now, if I plug in these values, if I plug in x as 1, I got 1. So one images with 1. If I plug 2, I get 0.2. If I plug 3, I get 0 point something. If I plug 4, I get 0.25. If I plug 5, I get something 0 point something. But none of the values are coming for negative here. No negative values. No values are here. No negative values are. So this is the possible outcome values. That is called codomain. But the range is coming only this part. All positive values, not negative value. So every element of set A has an image in set B. So it is a 1-1 function, but it is not an onto function, since all negative values does not have any pre-image in domain. Let us prove it. To prove 1-1 function, we know that let x comma y belongs to natural numbers, such that f of x is equal f of y. We know f of x is 1 over x and f of y 1 over y. If I cross multiply, I got x is equal y. We know the condition. If I prove x is equal y, then the given function is 1-1. So the given function is 1-1. Now I have to check whether the given function is onto or not. Based on the figure, it is not an onto function, since y is equal to 1 over x and x is equal 1 over y. If I plug in the negative values here, if I plug in, for example, if I plug in negative 1, then x must be negative 1. So the negative 1, the pre-image of this codomain must be negative 1 somewhere here. But negative 1 is not in my domain. Negative 1 is not in my domain. So it is not an onto function. Since negative 1 belongs to codomain and negative 1 has no pre-image in domain. That is why the given function is not an onto function. So a general sentence: there exists y belongs to codomain and has no pre-image in domain under the function f of x is equal 1 over x. Therefore, the given function is not an onto function. Check injective, which means 1-1, and surjective, which means onto, of the following function. Function f is equals f n turns to n, natural numbers to natural numbers, defined by the function f of x is equal x squared. I recommend to draw the figure first and then decide whether the given function is 1-1 and onto. This is the given function, y is equal x squared. Okay. All natural numbers to natural numbers. All natural numbers are 1, 2, 3, 4, so on in domain. If I plug in natural numbers x as 1 in the given function, y is 1. Yes. If I plug in 2, I got 4, because 2 square will be 4. 3, it will be somewhere here 9. 4, 16, something. So every element of domain has a unique and different image in codomain. But so it is a 1 function. But if you see this figure, 2, 3, 5 and many more do not have any pre-image in domain. So it is not an onto function. I proved it. But let us see this one. Given function and natural numbers through natural numbers defined by f of x is equal x square. We have to prove we have to check for 1 condition. If x comma y, if any x comma y belongs to natural numbers such that f of x is equal f of y. F of x is nothing but x square is equal f of y is nothing but y square. Now, if x square is equal to y square, then it is x is equal y. Please do not get confused, teacher. X is equal plus or minus y. No. In this, we have some conditions. Try to make a note of these conditions. If x square is equal y square for even powers, then x is equal y if x and y belongs to natural numbers. If an x and y belongs to real numbers, then it is not equal. So in this question, x and y belongs to natural numbers. That is why I'm saying x is equal y for even. Okay, for even powers. So the given function is 1. Now check for onto function. Now based on the figure, you can see since 2 which belongs to codomain and 2 has no pre-image in domain, so this is not an onto function. A journal sentence you will write like this: there exists y belongs to n, which is a codomain and has no pre-image in domain, under the function f of x is equal x square. So the given function is not an onto function. Second part of question 2. If function f z to z, which means integers to integers, okay, defined by the function f of x is equal x square. What are integers? All negative and positive numbers, including 0. I recommend to draw the figure first and then decide whether the given function is on 1 or on 2. This is the function y is equal to x square. Integers to integers. If I plug in any integer, for example, -2 in x, so -2 power 2 is nothing but 4. So it has an image. Now, if I plug in -1, I'm getting 1. If I plug in 0, I got 0. If I plug in 1, I got 1. Now, based on this figure, check whether the given function is 1, 1 and on 2. At first, I don't need to check 1, 1 and 2 because it is not a function itself. Every element of set A must have one image, but 2 sets have same image. That means it is not a function. If it is not a function, that means it is not 1, 1 and on 2. Check. Given function z to z, integer to integer, and defined by f of x is equal x square. For 1, 1 function, let x comma y belongs to z such that f of x is equal f of y. F of x is nothing but x square and f of y is nothing but y square. So x square is equal y square, which means x is equal plus or minus y. X is equal plus or minus y. Then x is not equal y. Since y, just try to remember this note, for even powers powers. If x square is equal y square, then x is not equal y where x and y belongs to integer. If x and y belongs to integer, then they are not equal. If x and y belongs to natural numbers, they are equal. There are three things: 1 for natural numbers, 2 for integers, 3 for real numbers. For integers, yes, it is equal. For natural numbers, for integers not equal, real numbers not equal. So in this question, x and y belongs to integers, that is why x is not equal y. In the previous question, x and y belongs to natural numbers. So the given function is not a 1, 1 function. Now we have to check on 2 function. From the image, it is clearly that there are pre-images of all positive numbers. For negative numbers, we don't have any pre-image. Since -2 belongs to codomain, and has no pre-image in domain. That is why the given function is not an onto function. Journal sentence, we write it like this: there exists y belongs to codomain and has no pre-image in domain under the function f of x is equal x square. That is why the given function is not an onto function. Part 3 of question 2. F from R to R, real numbers to real numbers, defined by the function f of x is equal x square. Here all real numbers means all numbers, positive, negative, decimal, fraction, whatever. So all real numbers to all real numbers. If you draw a figure, a rough figure, any real number, put in set A and plug in the function and write the outputs. So I put some numbers. It's an example just to understand. If I plug in -1, I'm getting 1. If I plug in 1, I'm getting 1. So set A, 2 elements have same image. So it is not a function. If it is not a function, then I don't need to check it is 1, 1 or onto. It is not on 1, 1 as well as onto. Let us prove it. Given function is defined as f of x is equal x square. Let x comma y belongs to 2. For 1, 1 function, let x comma y belongs to R such that f of x is equal f of y. F of x is x square and f of y, y square. So x square is equal y square. Then x is equal plus or minus y. But x is not equal y. Because you need to remember, if the power is even, if x square is equal y square, then x is not equal to y. For x comma y belongs to any real number. If x comma y belongs to natural numbers, they are equal. For integers, they are not equal. For real numbers, they are not equal. If x is not equal y, then the given function is not a 1, 1 function. Now check for onto function. If I plug in any real numbers, I'm getting output as positive only because it's x square. So the outputs are positive only. So there is no pre-image for the negative integers of set B of codomain. So the given function is not onto. See here, since -1 belongs to codomain, I don't have any pre-image. In domain. So if I don't have any pre-image, then it is not an onto function. So journal sentence, there exists y belongs to codomain and has no pre-image in domain under the function f of x is equal x square. So the given function is not an onto function. Part 4 of question 2. f from natural numbers to natural numbers given by the function f of x is equal x square. I always recommend to draw a rough figure to understand whether the given function is 1, 1 and onto. Now given function y is equal x cube, and here all natural numbers. All natural numbers means 1, 2, 3, 4, so on. And two all natural numbers, 1, 2, 3, so on. If I plug in x as 1, then I got y as 1. So 1 make images with 1. If I plug in x as 2, I got 8. If I x as 3, I got 27 somewhere here. So all elements of set A has an image in codomain. So it is a 1, 1 function. But if you see few numbers, 2, 3 and so on, they don't have any pre-image. So it is not an onto. Let us prove it. Given f from n to n, natural numbers to natural numbers, and function f defined as x cube. For 1, 1 function, let x comma y belongs to natural numbers, which is set A domain, such that f of x is equal f of y. Then we have to show that x is equal y. What is f of x? X cube. And what is f of y? Y cube. So x cube is equal y cube, which means x is equal y. Since now this is a note for odd powers. X cube is equal y cube. If x cube is equal y cube, then x is equal to y, where x comma y belongs to natural numbers. If x, y natural numbers, then x is equal y. If I prove x is equal y, that means the given function is 1, 1. Now we go for onto function. If you see the picture, I don't have any pre-images of 2, 3, 4 and many more numbers. So I will write like this. Since 2 belongs to codomain and 2 has no pre-image in domain, then it is not an onto function. Generally, we write like this. There exists y belongs to codomain and has no pre-image in domain under the function f of x is equal x power 3. So the given function is not an onto function. Part 5 of question 2. F such that from z to z, integers to integers, given by the function f of x is equal x cube. As earlier I told you, first draw the rough figure, plug in any values, integers, all negative numbers to positive numbers. So I plug in all negative numbers, starts from 2, you can give it any other numbers. I plug in x as negative 2 here, I got negative 8. If I plug in x as 1, negative 1, I got negative 1. If I put 0, I got 0. If I put 1, I got 1. If I put 2, I got 8 somewhere here, down. If I put 3, I got 27. If I put 3 here, a negative 3, I got negative 27. So in this picture, I can clearly observe that all the elements of set A has an image, a different, unique and different image in set B. That means the given function is 1, 1. But if you see this one, negative 2 and 2, some other numbers are there, okay, in set B, has no pre-image in set A, in domain. So this is not an onto function. Let us prove it. Given function is defined as x cube. For 1, 1 function, let x comma y belongs to integer z such that f of x is equal f of y. We have to show that x is equal y. Then it is 1, 1. F of x is x cube and f of y is y cube. Then x is equal y. Try to remember this note. If x cube is equal y cube, odd powers, odd powers. Then x is equal y. For any x comma y belongs to integers. For any x comma y belongs to integers, real numbers, and natural numbers. If the power is odd, then they are equal. If the power is even, then they are equal only in natural numbers, not in integers or real numbers. So in this question, xy belongs to integer. That's why x is equal y. So the given function is 1, 1. For on2 function, it is clearly observed that -2 and many other elements of set B does not have any pre-image in domain. -2, which belongs to codomain and has no pre-image in domain. In general, we write like this: there exists y belongs to codomain and has no pre-image in domain under the function f of x is equal x cube. So the given function is not an onto function. 3. Prove that the greatest integer function f r to r given by f of x is equal x is neither 1, 1 nor onto, where greatest integer function is denoted by like this, which means less than or equal x. At first, we need to understand what is greatest integer function. Greatest integer function is nothing but round down to the nearest integer. Round down to the nearest integer. Check. We have few examples. If it is 1.3, it round down to the nearest integer, which means 1. 2.9, which means 2. Sorry, I wrote 1, which means 2. 0.3, which means round down to the nearest integer is 0. -1.3, round down, it should be down, so it should be -2. By mistake, I wrote -1. So these are the greatest integer functions. We have to show that these greatest integer functions is not 1, 1, not onto. I recommend always draw a rough figure. All real numbers to real numbers. This is what the function define. Okay, real numbers to real numbers. Real numbers means all positive, negative, integers, fractions, decimals, everything. So I wrote few examples. If I put -1 of greatest integer function will be -1, whereas -0.5 is nothing but -1 because because of round down to the nearest integer, which is -1. Like this, if I take 1, 1.2, 1.3, 1.4, it round downs to the nearest integer is 1. So if you see this figure, which means it is not a function, because two elements of the domain couldn't have same image. If it is not a function, that means it is not a 1, 1 as well as onto. Let us prove it. At first, what is given? This is given. Function f r to r is defined as greatest integer of x. 1, 1 function. We have to prove it is not a 1, 1 function. We know that let 1.3 and 1.4 belongs to domain such that f of 1.3 is equal f of 1.4. F of x is defined as greatest integer function of x, which means greatest integer function of 1.3, and f of 1.4 is nothing but greatest integer of 1.4. The greatest integer function of 1.3 and 1.4 is 1 only. But 1.3 is not equal 1.4. 1.3 is not equal 1.4, which means the given function is not 1, 1. Now we have to prove it is not onto function as well. If you see the figure, if you see this picture, all these elements elements of set B do not have any pre-image in domain. So it is not a one onto function. If I'll give you one example, it's more than enough. Since 1.2 belongs to codomain, 1.2 belongs to codomain, and 1.2 has no pre-image in domain, so it is not an onto function. A general statement we write like this: there exists y belongs to codomain and has no pre-image in domain. Under the function f of x is equal greatest integer function of x. Therefore, the given function is not onto. Show that the modulus function from R to R given by f of x is equal modulus of x is neither 1 nor onto. At first, what is modulus function? Modulus functions means its absolute value, which means, for example, if I have modulus of -2, the result is always +2. As well as if it is modulus of +2, it gives positive result. This is modulus function. So modulus functions will give you the result always positive. So at first, what is given? We draw a diagram based on the question from real numbers to real numbers. You consider any real numbers here, positive, negative. On the number line, you can choose any numbers. I choose like this. You can choose any number. -2, modulus of -2 gives you the result 2. And modulus of 2 gives you the result 2 again. So if two elements of domain gives you an same image, which means it is not a function. If it is not a function, which means it is not 1 as well as onto. Let us prove it. Given function from R to R is defined as modulus of x. For 1 function, let us choose any numbers. I choose let -1, 1 belongs to domain such that f of -1 is equal to f of 1. F of -1 is nothing but modulus of -1. Okay, and modulus f of 1 is modulus of 1, which gives you the positive result too. Check. The modulus of -1 and modulus of 1 gives you 1. But -1 is not equal 1. But -1 is not equal 1, which means the given function is not 1. Now, check for onto function. Onto function, just see the graph. I don't have any pre-image of negative elements of codomain. I don't have any pre-image of negative values from codomain. So it is not an onto function. Since you can just write one example, -2 belongs to codomain and -2 has no pre-image in domain. That's all. A general sentence you can write like this also. There exists y belongs to codomain and has no pre-image in domain under the function f of x is equal modulus of x. Therefore, the given function is not onto.